okay, it gets the same value. That is not at all obvious, okay? So I think that would be a genuine discovery of something that you found. And it's important enough that I want to write it down. Exp of a plus b is actually the same thing.
E power a plus e power b. Same as that e power a plus e power b is equal to e power a plus b,
Yes.
and it's equal e power q.
How this property has to satisfy, or I should say has to equal, x squared 1 half, which is of course x squared 1, which let's say we're using the shorthand and we call it e. So what does that mean? X squared 1 half, or negating, and then if you have certain continuity restrictions, that will let you extend from rational numbers to all the reals, but that's a technical point you don't need to fuss over for what we're doing right now.
1 and e power x. So this is equal e power x.
It only makes sense
Ah!
in real numbers. Because as soon
I
as you
know.
start introducing things like complex numbers,
Very clever.
you can't just add 1 to itself or subtract and divide and get the number.
Every time you must say like this, but in your mind you can think like this. It was e and power 1 and x. This you mean I mean you have to think 1 x power is a power power number.
Yeah.
Then next e.
Mm-hmm.
You can do
It's
this.
very useful for multiply by itself 3 times to get I cubed.
The circle and this one
Yeah.
is a pie.
Yeah, yeah.
And you said this one is pie. It's not right.
Yes.
You
Oh,
said
yeah.
you said this one is a pie.
Okay.
I want to say 90 see the picture and you will know why 90 degrees is equal I. It's
Okay.
this one. Then you want to know why.
Applications in the complex plane include a rotation component. And because I has a magnitude of 1, I have a square of -1, and this geometry lines up with that fact. If we
Paper, then I know.
Okay, this means I power negative and equals
the one, okay?
I cube it, right?
Yeah.
Okay. Let's go.
Okay.
when we multiply by I, we get 1. -1, that's also... So now we just have an itty-bitty vector that is of magnitude 1/6. And then they just get smaller from there. The next comes on our visual, that checks out. It looks like the real part is a little above 0.5, 0.554, I believe that. And my hope is that Euler's formula might have started off mysterious, but mysterious in a bad way, okay? Because when you initially... So that I squared means that it's negative, okay, pointing to the left. And I guess the magnitude is pi squared over 2.
So why this teacher said it was shrinking? Because you see, this was getting bigger and this was getting bigger. But this was getting bigger faster than it. But why is it going faster than it? Because this was factorial. Factorial.
Yeah.
So the teacher said it was shrinking.
Put in, it puts us on a unit circle at that angle. Now this is especially mysterious when we consider clear that the function would be periodic, right? Because as theta increases, more and more of the vectors become relevant, because it takes longer and longer for the denominator of our terms to win out, and yet they stayed very nicely constrained onto the unit circle.
Let's make an example. 1 times plus 2i times 1i plus 2. This one. And first the 1 times this one, then the 2i times this one. So 1 times See, now we get the answer. It's 5i. Yes, but what did it mean? Why? Let's see the picture. First, we see this one. 1, 2. 1, 2. Wait, here's this. 4. Now we see. Now this is 1. This is 2i. This is 1, 2i. So it's this point. Now we use 1 times 1i. This is 1 times 1i equals 1i. And 1 times 2 is 1 times 2 is 2. And this is the same. This is the same. But now this one, the problem is, what did I mean when you times I? It means the real axis, a number on the real axis rotate her 90 degrees from this direction. If you said you this direction, it will be negative I. And it was I squared, so it means rotate her 90 degrees, then rotate 90 degrees again. So it's here. So this one is negative 2. Negative 2. So this one is negative 2, and this one is 2. So make together is 0. Then this I and 4i make together 5i. Expansion complex 0, 1. This thing actually is e power I. Then you put the I in the expansion, then you get the result. Is this thing, and it was 2 parts. This part is real part. This part is imagination part. And then you can call this one 0.54. This one is 0.84i. Then we got two numbers, 0.54 and 0.84i. And 0.54 is just a little bit more than 0.5. 0.5. Then you see 0.84i is this one. And you go into here, and so you can say you get this point, or you get this, or you can say you get this vector.
Very fascinating fact that evidently, when the vectors are rotating according to powers of I, and when their lengths are changing according to powers of pi divided by n.
What did the theta means? The left theta means just how many 1 radian in the unit circle. And then the right part theta means just how many it means. The equation's left part means just a point to walk on a unit circle. Then if theta equals pi, it means just a pi radian. And the right part means just like the teacher said, this plus this plus this and plus together. He said like it. And finally the sum of all of them just is negative 1. Then what does negative 1 mean truthfully? Just this one is just you think is e power I pi, because theta equals pi. So this you can see e power I pi equals negative 1. This is what Euler did. We'll put 0 and pi I to the expansion, and we'll get the result. This one is almost negative 1, so we call it this one negative 1. And this is almost 0, 0i, so we call it 0i. Then put them together, then we go back. And because this one was a factorial, so it was shrinking very fast. Then, truthfully, you see this one was a it's almost the negative 1 point. And truthfully, it was just negative 1 point, go a little left and then go a little up at this point. Then in this point, and you around 2 pi I, then you will go back to the point where you start. Actually, what I mean is e power I pi equals -1 plus 0I. Then what it means, just this point and you around 2 pi I, then you will get back the point where you start.